Now it's time to talk about how to use real-time event streams in Microsoft Fabric. In this section, you'll hear how to create event stream source and destinations, along with how to use those sources and destinations to ingest, capture, and transform a real-time stream of data and route it to destinations for further processing and analysis. Microsoft Fabric Event Streams works by creating a pipeline of events for multiple internal and external sources to different destinations. You can think of it as a conveyor belt that moves data from one place to another. Event streams enable you to capture and process real-time events without needing to write any code. You can set up event sources, destinations, and transformations in the event stream, enabling you to collect, filter, aggregate, group, and combine data from real-time sources before loading it into the destination. Some of the main benefits of Microsoft Fabric event streams are you can capture, transform, and route real-time events to various destinations with no code experience. You can use the drag and drop feature to make your event data processing logic without writing any code. There are multiple source connectors to get event data from different sources, such as the Azure Event Hubs, the Azure Internet of Things Hub, Azure Storage, Apache Kafka, and others. You can send data to a wide range of destinations for further analysis and processing. You can attach multiple destinations in an event stream to ingest data from a single source into multiple stores. Event streams use a scalable infrastructure that manages resources automatically. The scalable infrastructure helps you to capture your real-time events, making streaming ETL or extract, transformation, and load operations possible. You can use the event stream visual editor, shown here on the right, to design your pipeline by dragging and dropping different nodes such as sources, destinations, transformations. You can also see the event data flowing through the pipeline in real time. Microsoft Fabric Event Stream handles the scaling, reliability, and security of your event stream automatically. The best part, you don't need to write any code or manage any infrastructure to use Microsoft Fabric Event Stream. Let's review some of the main components of an event stream. Number one, sources. These are where your event data comes from. You can pick the Azure Event Hub, sample data, or custom app as your source type. You can also choose the data format and consumer group of your source. Number two, you can add transformations that filter or aggregate the data as it's processed from the stream. Transformations include common data operations such as filtering, joining, aggregating, grouping, as well as temporal windowing functions that enable you to analyze data events within discrete time periods. And three, destinations are where your transformed event data is stored. For example, you can store the results of your streaming process in a table in an Eventhouse or a lakehouse. Or you could redirect data to another event stream for further processing, or to Activator to trigger an action. You can use the event stream editing canvas to add and manage your sources and destinations. You can also see the event data. Check the data insights and view logs for each source or destination. At their simplest, event streams capture real-time data with a source and load the captured data into a destination. Event stream sources in Fabric Real-Time Hub can include, among others, Azure Event Hub, specify the data format and the consumer group of the Event Hub in Azure. You can also create a cloud connection to Azure, to your Azure Event Hub with the appropriate authentication and privacy level. Azure Internet of Things Hub, this is a SaaS service used to connect, monitor, and manage millions of Internet of Things assets with no code experience. Azure SQL Database Change Data Capture, or CDC, identifies and tracks changes to data in a database, enabling real-time or near real-time data movement, and other change data captures from various databases noted here and other providers. You can use Fabric Workspace events, which are events triggered by changes in the Fabric Workspace, such as creating, updating, or deleting items. With Fabric Event Streams, you can capture, transform, and route these events for in-depth analysis and monitoring within Fabric. This integration offers enhanced flexibility in tracking and understanding workspace activities. You can use Azure Blob Storage events as system triggers for actions like creating, replacing, or deleting a blob. It supports both streamed and unstreamed events. You can also create your own custom endpoint using the REST API or software development kits provided by Microsoft Fabric to send event data from your custom app to your event stream. Lastly, you can use sample data as your source for out-of-the-box sample data provided by Microsoft Fabric. There are a few different sample data sets to choose from, like IoT, retail, or finance. You can also adjust the frequency and duration of the sample data generation. Microsoft Fabric Event Streams also support the ability to send data to the following destinations in an enhanced mode. So number one is Eventhouse, which can funnel your real-time event data into a KQL database, enabling you to use Custo Query Language or KQL for data interrogation and analysis. Storing your data in a KQL database unlocks the potential for enhanced comprehension of your event data and the creation of comprehensive reports and dashboards. Number two, you can use the Lakehouse to pre-process your real-time events before their ingestion into the Lakehouse. The events are transformed into a Delta Lake format and later stored in specific Lakehouse tables, facilitating your data warehousing needs. The custom endpoint feature is advantageous when you aim to transform real-time data to an independent system not hosted on the Microsoft Fabric. Number four, Derived Stream. This is a specialized destination created post-application of stream operations like filter or manage fields to an event stream. It represents the altered default stream after processing, which can then be routed to various destinations within Fabric and monitored in the real-time hub. And lastly, number five, Fabric Activator can be used to trigger automated actions based on the values in your streaming data. Remember that you can attach to multiple destinations within an event stream at the same time without impacting or colliding with each other. The drag and drop event stream editing interface offers a straightforward and user-friendly method for constructing complex event data processing workflows. You can transform data in an event stream by applying the following transformations. Number one, you can use filter to filter events based on the value of a field in the input. The transformation keeps the values that match the selected condition, such as is null or is not null. Number two, you can use aggregate to calculate an aggregation like sum, min, max, average, and more every time a new event occurs over a period of time. Number three, you can use the group by transformation to calculate aggregations across all events within a certain time window. Number four, you can use the union transformation to connect two or more nodes and add events with shared fields with the same name and data type onto a table. Number five, you can expand to create a new row for each value within an array. Number six, you can use the join transformation to combine data from two streams based on a matching condition between them. Windowing functions are a way to perform operations on the data contained in temporal windows, such as aggregating, filtering, or transforming streaming events that occur within a specified period. The windowing functions are useful for analyzing streaming data that changes over time, such as sensor readings, web clicks, online transactions, and more. They provide great flexibility to keep an accurate record of events as they occur. Use the event processor editor's graphical interface to define the logic for processing, transforming, and routing event data. Temporal windows are essential for organizing and analyzing streaming data based on time intervals. Let's explore the different types of temporal windows, how they work, and brief use cases. Tumbling windows divide incoming events into fixed, non-overlapping intervals. Imagine you want to aggregate data every hour. Each hour is a distinct interval with no overlap. For example, if you have a tumbling window of 5 minutes, events are grouped into distinct 5-minute intervals without any overlap. Maybe we need to calculate or aggregate sales data every hour. Next, we have sliding windows, which include events in fixed, overlapping intervals based on time. This is perfect for maintaining a continuous view of data with a sliding window of 5 minutes and a slide interval of 1 minute. Each window overlaps with the previous one by 4 minutes. Useful to continuously calculate the average number of visitors over the, let's say, the last 10 minutes, updated every minute. Now let's talk about session windows, which divide events into variable, non-overlapping intervals based on gaps between activities. This is ideal for tracking user sessions and activities. If there's a gap of 10 minutes between user activities, a new session window starts after the gap. So this is useful to group user activities into sessions based on inactivity gaps or analyzing shopping behavior. Next, we have the hopping window, which divides incoming events into fixed overlapping intervals. This is useful for periodic snapshots of data with some overlap. With a hopping window of 10 minutes and a hopping interval of 5 minutes, each window overlaps with the previous one by 5 minutes. This is useful for periodic health checks with overlapping intervals. Finally, we have the snapshot window, which groups event stream events that have the same timestamp. This is perfect for analyzing events occurring at the same time to detect anomalies in a financial system. All events with the timestamp that are the same are grouped together in a snapshot window. To summarize, understanding and utilizing temporal windows in Microsoft Fabric can significantly enhance your ability to process and analyze real-time data streams. Each type of window serves a specific purpose and is suited to different scenarios. Now let's see how to ingest real-time data with Eventstreams in Microsoft Fabric.
Hello, and now we are ready to start a lab demo number 8. This is Ingest Real-Time Data with Eventstream and Microsoft Fabric. And I already have the workspace created, as you can see here on the screen. And so what I'm going to do in this section is I'm going to be creating an Eventhouse, an Eventstream. We'll be adding a source, a destination, and then we'll go through and we'll query our data and find out a little bit more about how to modify some event data as we go. So I'm going to create an event house from here in my workspace. And we should be able to find the real-time tools in our list here. So we have real-time tools right here. So I'm going to go ahead and do my event house. And I'm going to call the event house really anything I'd like. But what I'm going to do is I'm going to do the DP-700 Lab 8 event house. So we can kind of find that in a list here. I'm going to go ahead and create that. Now it's going to take a moment to make that. And I'm going to close out of this Get Started. I'm going to close out of this little helpful pop-up box there to get me acquainted with the event house. And then what we'll note is we have the name of the event house, plus we also have the database with that same name, but we don't currently have any data in it. So what we want to do is I'm going to go out to the database right there, the KQL database, and I want to get some data. So I'm going to choose Get Data from right here. And you can see I have a lot of options for getting data, but I'm going to go ahead and create a new event stream, and it's going to be called Bicycle Data. I'm going to hit Create for that. It's going to take it a moment. And we're going to see some more helps to help make our event stream here. I'm going to have it use some sample data as my source. And I'm going to go ahead and call my source bicycles. And then there's a lot of sample data you can get, and one is called bicycles. So that's the one we're going to be using here. And I'll go ahead and add that. And you can see it's been added to our list. We have that stream here. We have bicycles. And if we select it, we can see maybe there's data in it that we can look at. It takes a little bit to refresh it. But okay, so we have the two that we have here, which is helpful. Our source and our event stream is here. Now what we're going to do is we're going to want to configure a destination. Where are we going to put all this information? So I'm going to choose our option here. And notice there's a bunch of things you could do to transform it. There's a lot of good stuff in there. But what I'm going to do is I'm going to go ahead and go back to the event house here as my destination. And what I'm going to do to configure this is I'm going to tell it that I'd like to do data ingestion will be event processing before ingestion. And I'm going to call my destination name here bikes table. And I'm going to call the workspace from earlier that I created here. And it should be in here somewhere. And then my event house is handy right there. My KQL database is also there. And then my destination table is going to be bikes. And the format on this is fine at JSON. So you can see we have a lot of little options in there that we've set. And whoops, I don't have a bikes table. I forgot. I need to create a new one. Okay, so it didn't find it in the list. So I got to click on Create New. And I'll make a new table there called Bikes as my destination. There we go. Okay, I'm going to go ahead and save that. And we should note that there's no preview of data there because we added the destination, but we haven't really put anything in it just yet. So I'm going to go ahead and publish this. It's going to take a moment. And notice that bikes table is going to be loaded. So it's taking from that bikes sample source using the stream, the event stream, to get to my bikes table. And it's going to take it a moment to do this. Once it actually goes through, what will happen is we'll be able to preview it. So it takes it just a bit to do that, and we'll wait for it. Now, after this, we are going to query against it to look at our data, so we'll get a sample of more KQL queries. We're also going to add another transformation event here to our pipeline area here. So we'll set this up. And I'm hoping you're liking how a lot of this is all graphically done. We're really creating workflows here. But we'll come back and add to this. Note too that once that bikes table is loaded, we can go in and besides getting the preview, we can see details on it, insights, and also runtime logs. So it's coming up right there. Okay, that looks good. Okay, so you have a lot of info there that you can grab from it with the preview. But what we'd like to do is we'd like to go in and maybe query it. So I'm going to go back to my KQL database there, and I'm going to refresh it because we just added a few new things. So the refreshing is up at the top here. And there you can see bikes. And you can see all the fields that make up bikes. And what we want to do is we want to query it. So I'm going to have to go to the query set. We'll go right in there. And what we'll do is we're going to ask it a little bit about bikes. First, what I'm going to do is I'm just going to have it show me the first 100 records in bikes. Now, we kind of saw that in the preview, but I want to see it here too, just so we can get on the same page. And we can see those first 100 records right there. Then I want to go down here and I'm going to paste in another query. This is going to show us the most recent data records that have been ingested within the last 24 hours. So that could be a very helpful query. I want you to see how simple a lot of these queries are, maybe even a little easier than working with T-SQL. So we're going to come back and query some more as we go through, but I think this is helpful. I'm going to do one more query because I'm thinking about it right now. And that is, I'm going to ask it to count the records in bikes. So you can see a good total there too. Okay, so that's good. Now what I'm going to do is I'm going to add another event to my event stream. So I'm going to go back to it here. And we have an option up at the top that we can select. So once I select this, and we're giving it a moment, I think it's trying to load data right now, but I'll select that event stream. And then what I'll do is I'm going to add in another event. So we're just letting it update itself for a moment here. And I'm going to actually add a transformation event. And there's a lot of them you can select from. But the one I'm going to choose is the one for working with grouping data. So we'll get into that one in just a moment. We're just letting it load for a second here. And then what I'm going to do is I'll get into our toolbar. So let me edit first to do that. And then right here is where I can get transform events. And you have a few to choose from there, one of which is group by. So I'm going to add group by to the mix here. And when I add group by in, what I'm going to do is I'm going to go ahead and connect it to the stream here, our bike data stream. And then I'm going to have to set it up. So I'm going to do a little bit of group by. I'm going to give it the name group by street, so that way we can identify it. And I'm going to have it do an aggregation. I'm going to have it aggregate using sum, and I'm going to have it focus on the field, no bikes. And I can change the name of this aggregation if I'd like, but I'm going to go ahead and add it so that we can use it. And then I'm going to add in a little bit more information to the settings here. I'm going to have it group by aggregation. I'm going to choose street. And then I'm going to keep all the other settings that are here. I'm going to click on save. And we get an error. Why do we get an error? Well, it could be because we need to add a destination. So what I'm going to do is I'm going to go ahead and just kind of hover over this here and click the plus. And I'm going to have it write it out to the Eventhouse. And I'm going to once I include that there, I'm going to go ahead and do some configuration of Eventhouse. So this is going to be, let's see, event processing before ingestion. The destination name, I'm going to call it Bikes by Street Table. And then I'm going to pick my workspace. Among this list of a lot of workspaces here, I'm going to pick up my Eventhouse. I'm going to pick up my database. And I'm going to create a new table here because I think I only have the bikes table right now. I'm going to create a new table to store this data, and it's going to be bikes by street. And then I'm going to click done, and it's going to be in the JSON format. I'm going to go ahead and save that. Then what I'm going to do is kind of take a look at it there, and it looks pretty good, I think. And I'm going to publish this. So we don't have any errors anymore, and you get a little bit more detail in here, as you can see. But I'm going to go ahead and publish this. And it's going to take a moment to kind of walk through the rest of that loading. You can see it's trying to load right here, the bikes by street. So we're going to wait for that a little bit here. Kind of like what we did earlier where we had to wait for it to load into our destination a bit. And then once it's loaded, we'll get a preview down below. But we can also go in and do some queries against it, which is what I'd like to do. So we're going to see that we did a number of group by options here, which are hopefully helpful. So our aggregation by sum of number of bikes, and it picked up that tumbling window of every 5 seconds. So that's the timer on it. So we're just going to get it to load some data there, and then we'll run some queries. Now, the name of the table that we're going to use is that bikes by street when we want to run our query. So that's going to be a little interesting. It's done a little bit different in KQL. We'll see in a moment here. But we'll let this run for just a sec. Notice we have 2 destinations. They're both going to an event house, but to different tables in that event house. And I love the way this is all graphically done. It's a very good complement to what we've already learned with our pipelines, and a really big complement also to what we've learned even in our data flow gen 2. Okay, so it looks like it's active, and then there we get our little refresh. So we can see it has street, some number of bikes, and then window and time. So let's go query it. I'm going to come back out here to our event house. And what I'm going to do is get right into that data query. I'm going to refresh this because I'm going to make certain, I'm going to refresh it. To refresh it, you have to go up to the database, and then you see it right there. And you can see the bikes by street. You can see bikes. And we're going to query the bikes by street. So to query that, I'm going to go into the query set, and I'm going to modify this a little bit. So I'm going to add that in. Now notice when I do bikes by street, it has to be inside square brackets because it has dashes and different things inside it. Plus it also has to have those single quotes. So the square brackets and single quotes, and when I run this, it should be able to find it for us. And there you can see bikes by street, the first 100 records. And then I'm going to go ahead and take a look at another option, and that is I want it to give me the total number of bikes per street within each 5-second window. So I'm going to run this one, and we'll see what we get there. So that looks good. And I can run that again and get a little bit of a different number. If I wait just a little bit, I might be able to see a little bit of a different number. Yeah, this should change on a regular basis. Remember, this is real-time information coming in. So every time I query it, I get a different result. As long as I wait just a little bit to do it, it's going to be reflected. Now, I also would like to see the count of the records in that table. So I'm going to pick this up right here. I'm going to set it right there, and we'll go ahead and get the count right here. And we're up to 142 records. Okay, and if I run it again, Notice the changes. Again, you have to wait a little bit of the interval to make that happen. Okay, so this looks good. This looks really good. Getting this to work here, I think it's very easy. I hope you enjoyed it. And I hope, too, to see you in our next section. More on real time here inside of Fabric.
Now let's do the knowledge check. Question 1. What is the primary function of Microsoft Fabric event streams? Answer: ingesting and transforming real-time data. Question 2. What do temporal window transformations enable you to do? Answer: aggregate event data in a stream based on specific time periods. Question 3. What is the purpose of the Fabric Activator destination in an event stream? Answer: data sent to an activator destination can be used to trigger an automated action based on data values. To recap this section, we reviewed the components of event stream sources, transformations, and destinations. We also discussed the different sources that can be used for an event stream and destination, along with a few use cases. Lastly, we looked at the 6 event stream transformations. We defined temporal windows and the 5 temporal windows: tumbling, sliding, session, hopping, and snapshot. For further information on how to use real-time event streams in Microsoft Fabric, please see the link here.